Like I think many of you here, I work as a data engineer. So my day job is actually building data pipelines using things like Kafka, Flink, Spark. So I don't do blockchains or Bitcoin on my day job. This is something just I grew up out of interest because I'm really passionate about distributed systems and what you can do with it. And Bitcoin beyond the financial aspect, beyond what you can do with it today, beyond the trading aspect of Bitcoin. So in this talk, we're going to talk about not especially Bitcoin, we'll talk about it, but mostly blockchain and some of the work that has been going on to actually use blockchain, not just for financial application, like I said, like asset management, but beyond the standard application, but actually build blockchains within connected devices. So as I said, that this is me. So just so you know, I'm not a very, very blockchain expert. I just spend a lot of time reading papers on it, working on it for fun. So bear with me here. So today, when you all over the place, all of the time, you hear people talking about blockchains for almost everything. So let's build a blockchain for that, let's build a blockchain for this. And at some point, you're like, okay, what exactly do we want to do with blockchains? There's one, like every technology, there comes a time when it's overhyped, and at some point, we forget really what we can do with it. So the main aspect of blockchain has always been about being the things that underpins Bitcoin, but today, it's going beyond that. So I thought this thing was, this drawing from Dilbert was really interesting on how people are actually interested in blockchains, and somehow it's evolving too fast and it's hard to catch up. And like everything that's overhyped, they call the blockchain or Bitcoin the trust machine. You see it on every financial publications today. That at some point you're wondering exactly what's the point really with this blockchain. So, sorry, so. Before we go into blockchain, let's say a quick word about Bitcoin. I'm sure everybody here knows about Bitcoin. Who doesn't know about Bitcoin? Good, everybody knows Bitcoin. that's fine. So it's a peer-to-peer version of money, actually. It's a digital cryptocurrency money that has been created by this guy. We thought we know him, but it's not him eventually, Satoshi Nakamoto. And the real Bitcoin, in practice, beyond being a currency, a cryptocurrency, Bitcoin is actually a combination of many things. One of them is that a peer-to-peer architecture, actually, that you can see like BitTorrent, but with public cryptography concepts inside. And it's also a secure backbone network where all the transactions are actually public and available for everyone. And that secure backbone ledger where all the transactions are recorded is called the blockchain. So the blockchain is, like I said, a decentralized ledger for all the transactions. And it underpins the internals of Bitcoin network. And it builds out of blocks, which are actually a batch of transactions, and they are aligned in a sequential manner. So what you can see here is that one block has a batch of transactions, and it has a link to the previous hash, which is a link to the next block, and all the blocks are over there. I'll come back a little bit on how it works a bit inside. So one interesting thing with the blockchain is that every node of this distributed ledger has a full copy of all the data that's inside the blockchain. So you're a peer-to-peer organization. You don't have just a single part, but you have all the data that actually in the blockchain, which makes it very interesting compared to what you have with databases that are distributed database like Cassandra, where you can have all the data, but not always. You can't have all the data, of course, but you have some part of the data, but you can tune your consistency. The blockchain is, when you write something, it's usually broadcasted everywhere, so the data is available for everyone in the network. And the process of adding a transaction, because when you're actually using Bitcoin on the blockchain, what you're doing are transactions. So that's a simple, an interesting way to actually do a transaction. So when you doing a transaction, which is the process of either buying, mining, doing anything with Bitcoin, You broadcast your transaction. That's the first way. Every node will create a block with all the transactions that it has already seen. So that's the batch of transaction, and it randomly picks the data of the node and broadcast it to and broadcast the block to all other nodes. And the other nodes will have to receive and validate this block. And if it's validated, the block to the copy of the chain. So they had the block, they had to validate first the block of a transaction that's here, and they broadcast the node to all over the place, and then they add them to the copy of the blockchain. But that's an easy way, but in reality, it's a bit more complex than that. So this is how a real blockchain looks like. This is the data that's contained in the blockchain. So you have a header, that's the public, that's the non-encrypted, usually part of the blockchain, and timestamp, you have the difficulty, you have all the data that's there. And you have something inside that's called a Merkle tree. So for those who do that, Cassandra, I think you know what a Merkle tree is. So it's very interesting, it's very good to summarize and verify the integrity of huge data. So that's very fine. So they are in many databases anyway, and they built using cryptographic hashes. Now, in the Bitcoin blockchain, what you have today is that all the transactions are actually fingerprinted using a digital cryptographic key. So you can verify them and make them auditable. And the cryptographic hash that's being used in the blockchain is something that's called the SHA-256, but it's applied twice, so they usually call it the SHA-256 double. So yes, that's what you have in a Merkle tree. So the way it looks like is that in the blockchain, like you have something like a linked list. You have the Merkle root that's here. That's where you have the roots of all the hashes. And the data is stored way below. When you have only one hash at the end, that's where you can store the data. So you double hash all the way around. And this allows you to store many data in just many transactions, or one transaction, many transactions in just one block. So that's why you can have actually multiple data in one block of the chain. So this is what you have with this is what the blockchain looks like, and this is what a Merkle tree does. So the Merkle tree is really important to all the blockchains. So every time you hear about blockchain, most of the time, when people talks about the architecture of the blockchain, you hear about Merkle trees. So another problem, if you have a distributed architecture like this, is how do you solve the issue of consensus? So consensus, for all of you who do that distributed system, you know that it's a hard problem. And the Bitcoin paper and the Bitcoin proclaims to actually solve the issue of consensus by solving the non-problem of the Byzantine general problem. There's still a lot of discussions with that, but yes, that's another thing. I'm not gonna dive into this kind of thing, but the way they solve the consensus is through a process called mining. So mining is the process where miners create blocks. But to create blocks, you need to solve an integral, actually a hard challenge, a cryptographic challenge, which literally actually does to doing real brute force. That's why when people talk about Bitcoin and blockchain, they say that it's just about wasting energy, because it's so expensive to actually create blocks to solve this cryptographic challenge today that mining Bitcoin is really expensive. And that challenge, the solving of that challenge, keeps increasing every time. So this is, for example, this is a graph. I don't know if everyone can see this. I took this just a few minutes ago from blockchain.info. That actually gives you an idea of how the challenge of solving this thing is growing, is actually expanding. So this is a bit hard. And this process, there's a process called proof of work, where you actually have a new block, you add a new block every 10 minutes, but to do that, it's a bit expensive. So how does it work? You have a big idea is actually to find a hashing key that's less than a certain value. So you do a random things that you hash until, and it's really expensive until you get the proper value. That's the proper value of your hash that's below a certain threshold. So to sum up how the Bitcoin blockchain works is that you have 10 minutes of transaction that are broadcasted to all the miners. The miners are the ones who create blocks. You send your transaction to miners. The miners try to create block. They have a puzzle. They do the proof of work to say that they have spent enough energy actually to be able to create new Bitcoins. And the successful miner will broadcast its proof of work to other miners. And once they verify it, they can restart the process. So the Bitcoin blockchain is built upon the idea is that creating new blocks has to be really expensive, really costly, but verifying the data and the new block that you have created has to be easy for all of it, so for other people. So that was Bitcoin. Bitcoin is popular. That's what started the tech. That's the basis. That's the baseline that we're trying to emulate today with its blockchain. But Bitcoin has actually sprung a lot of other altcoins, meaning other cryptocurrencies that look like Bitcoin but are not really Bitcoins. And those other cryptocurrencies actually come with their own blockchain. And one of the most heard of blockchain today that we've been talking about is the Ethereum blockchain. That's a new project, but it goes actually beyond what you have with Bitcoin. It's a huge blockchain. And what you can do, the advantage of actually having Ethereum is actually because it's really versatile. And it works on the state of contracts. Contracts are actually code that can be executed, that's stored on the blockchain, on the Ethereum blockchain, and can be executed by automatically executed. And those contracts do not have to be financial application. They don't have to be currencies. They don't have to be Bitcoin. They don't have to be money. They can be any type of application that you can write, actually. So you can build with those contracts things like currencies, voting systems, financial derivatives, talk a lot of applications, or even what we call today decentralized application. So basically what the Ethereum blockchain is the blockchain for everything, all type of application. That's what you can do with it. So at the core of the Ethereum is what's called a smart contract. But on the Bitcoin blockchain, the currency is Bitcoin. That's the unit of computing there. That's the Bitcoin. In the Ethereum world, it's called Ether. So Ether is what actually powers the underlying blockchain. So what you have is smart contracts. Smart contracts is actually a simple application, a block of code that's actually stored on the blockchain. So what you do is that to call a smart contract, like you have an idea here of what it looks like. You have an address. We'll see a little bit later. The balance, the method. So you still have the idea of actually money, but that money is a little bit Ether, but that's not the point here. But what you have is that you call that contract, and when it's done, the execution stops the moment that amount is gone. Now, you can use smart contracts without Ether. That's OK. It just looks like that's called an account. So in the Bitcoin, you have money, you have accounts, wallets, these kind of things. I didn't talk about them, but this is what you have. A smart contract, we see a little bit what it looks like. So here, what you have, it's just a small amount of data with an address, a balance, some fields that you can have. This is a smart contract that we did at a hackathon in Paris for a meetup, which actually a meetup smart contract. We use a blockchain to actually count the number of people attending meetups or not. So just for the sake of fun of it. So you can have an event. I don't know if you know the site meetup.com, but we wanted to build something like that, but totally decentralized, but using blockchain. So this is what the smart contract of a meetup looked like. So it's just a balance, an address, methods, events, and this you can write some codes inside of it. That code is called a decentralized application that's contained inside the smart contract. And to write smart contracts, you have a lot of application, a lot of ways to do that. You have a lot of languages. The most popular one that's actually supported by the platform is called Solidity. It looks it's not hard. It looks like JavaScript anyway. And on top of Solidity, they have built a lot of other contracts. That's a lot of other things. That's like a framework, a JavaScript framework called Web3, which stands for the decentralized web, but it's an application on top of that. So here's the code, and this is how it's actually translated within the C code, within the code inside the Ethereum blockchain. So here I can write a simple contract, the owner, what I'm going to transfer, all the data, just a simple code that looks like really nothing in particular. And like I said, you can build decentralized application. Decentralized application are actually composed on front end where you can interact and the back end where you store. The back end is usually a simple blockchain. So what you do is that you write a Solidity contract which looks like the language here that you have there. Yeah, sorry, that you have there. And you compile them using Web3.js, for example, here. And then you can try on locally. Locally, you can create your own Ethereum blockchain that it's usually called a test chain or a private Ethereum network. So that's something that's local, and then you can push them later on using these tools into the global Ethereum blockchain. So the Ethereum blockchain, as you can see here, has many implementations, but the free main implementation today, you have the Go implementation of Ethereum, and the Python implementation, and the original one in C++. We'll see why I'm talking about this in a minute. And the Go Ethereum platform, it's very interesting because it runs on many platforms, on Linux, OS X, and especially on ARM, which makes sense because we've tried to run these kind of things on small devices with low power. And since the Ethereum, I can do whatever I like. And one thing I didn't talk is that when it comes to performance on the Bitcoin blockchain, you have to wait 10 minutes for a transaction to appear to all the other nodes. Within the Ethereum blockchain, it takes something close to 10 seconds. And it's a little bit more performant. So this is the Ethereum implementation in Go, which is itself very interesting, which in itself is quite interesting. So, like I said, you can take them and run them in multiple platforms. That's what makes it interesting. And since it's Go, it has a low memory footprint, so it works very well on small devices with low power. So, what we actually have with blockchain is something that's secure, transparent, have a distributed consensus, and something that's auditable. And since we are at Buzzword, the blockchain being one buzzword, let's talk about another buzzword, which is the Internet of Things. I think unless you've been living under a rock, you have heard about IoT. I mean, that's all over the place. So they're predicting that we'll have a huge amount of connected devices in the coming years. I'm still not seeing them all over the places, but they're predicting that we'll have many of them. So that's nice already. And they're everywhere, literally. So on the thermometer, on your phone, you have things like this, a simple Raspberry Pi. And yes, they're all over the place. So the most popular one, when you want to have fun, if you want to tinker with IoT, you take small things like this. This is the Raspberry Pi that I put in, which is a nano computer. It has 1 gig of RAM and all of the things inside. And you can take the Arduino, which is really a microcontroller, but it's way more limited than what you have in a Raspberry Pi. And what you have today is that we have consumer electronics that are networked. So that was the first wave, and we have industry that are actually connected through all the devices. The devices are talking to each other, and the first wave is that everything that's coming up is going to have a device that's connected to the internet. So that's apparently where we're going. And the only issue is that what you usually have today is that all of these devices, when they try to talk to each other, they have to go through the internet. That's why they call it Internet of Things. So they always have some way to go through a central authority. And other things that has been seen lately is that you have a lot of security gaps in the IoT world. So like Jeep calling a lot of his vehicles to fix some of the bugs, and even people hacking your refrigerators. I mean, why do you hack my beer? Why would you want to do that? But yes, since something is connected to the internet, today there's always a security issue. So IBM came up with this thing is that the limitation today is that you have broken business models when it comes to Internet of Things, lack of privacy, they're not future-proof, and they're very expensive to deploy. So what you want to do is actually change that. And what you usually have before is that all the centralized IoT networks talk to a central authority. Today, they talk to the cloud, but it's still centralized. And what you want tomorrow is actually all those applications to actually be totally decentralized. So how do we come to a place where all the IoT devices are completely decentralized? So Samsung and IBM came up with a project called the Adept Project, published a paper on it. It's a simple proof of concept, but what they want to do is actually to tackle some of the challenges in the IoT world, the costs, the lack of trust, how to monetize, interoperability, discovery, authentications, and all of these problems that actually we know today that there are limitations when it comes to IoT. And what they actually want to see is something that they want to build digital marketplaces within a connected device, an economy of devices, but that are actually intelligent. So build intra-device agreements, direct payment between devices, and service resources between those devices. And the good thing is that they came up with a demo not so long ago, so it was kind of interesting. And they came up with an architecture where you have multiple layers, where you have devices that use blockchain technology to actually communicate with each other, and the layer where you can build application now. I'm not going to dive into this, but this is just a simple idea. So one of the use cases they came up with is to actually have a washing machine. So the washing machine actually buys itself the detergent if it lacks. So what it does is it's using Ether money to make orders using a blockchain to buy automatically detergents because it's lacking. So that's where it's going today. It might seem a stupid idea, but it's a good way to start. And the funny thing is that they came up with the real video at CES in January that actually demoed this thing. So it's kind of fun. And it's working quite well. So the device is going to make the order to check the detergent, going to notify the user, the owner of the device about the lack of detergent, and make a service request to a service vendor through the blockchain. And the same thing, they can validate the warranty through the vendors actually in the same way. So you have devices, what you have in the complete decentralized economy, not just between people actually using the blockchain, but even devices actually going through the blockchain themselves. So it's the same thing. And what they actually came up with is a universal digital ledger. So like it's a blockchain specified for the digital devices, where you can register a device, authenticate new devices, write contracts to actually have device make operation between themselves, and a lot of other things. So this is just a proof of concept, but it says that there's something that can be done with this. And like I said, today, most of the things are either centralized or semi-centralized, but we want something that's really decentralized. So, but it comes with a security risk as well. And the main problem with IoT today is really security. So there's this consortium called Chain of Things that did something similar to what you have with IBM, but they use solar power, solar mills. So instead, they actually use a way to log the data, and to prove that you can secure these layers, they added some checks and some challenges to work on. This is still a work in progress. So you have solar mill that actually gets the data, push the data inside a blockchain. This is instead of having Ethereum, this is the Bitcoin blockchain. So they're using something called BitSeed, which is a connected device with a blockchain already inside. So you just have to connect it. It goes through the blockchain itself. And it's still the same thing. So the main problem that you try to solve is actually to check the authenticity of the data. And how do you manage the security between the data from the devices to the ledgers? And how do you maintain that data securely? And how do you share those transactions? So those are still questions that people are still working on. But today you can do that within yourself. So if you want to get started, if you want to do your own IoT blockchain or put something like Ethereum in a Raspberry device, in Raspberry, for example, there's a way. Actually, just go on Raspnode. You download a specific distribution where you can order a specific Raspberry Pi with a blockchain already inside, or you can go yourself within your own Raspberry and install an Ethereum blockchain within yourself. That's something that's quite easy to do. It's just a Linux command. And then you can write your smart contract. I'm going to backslack it a little bit. So a smart contract is actually quite easy. This is just a blinker. You use something like Web3, the one that I mentioned the other day. The code is straightforward, just JavaScript anyway. You can write the same thing in Go as well, so you have to add the bindings for that. And then check the connection to your to the blockchain, your contract address. I'm sorry. Oh yeah, sorry. Is that okay? So the code is really not hard. So yes, this is it. And just go on the internet, writing a simple smart contract, and then using this to push a contract within an Ethereum blockchain. It works quite handily. It really has. So here I play within both the blink of the blockchain. This was supposed to actually set up a light between for a lamp, and that's it. So, and since we're in Berlin, I don't know, but there's this company called Slockit, okay. Yeah, it's a bit slow. There's this company called Slockit, and Slockit is actually a startup that started actually building Ethereum computers. Actually, they're building an embedded device, an Ethereum using Ubuntu Snappy. That's a low power Ubuntu platform, and within these devices, they actually built an Ethereum computer. And now they're going for something a little bit bigger. That's called the DAO. I don't know if you heard about it. That's the decentralized autonomous organization. Basically, it's building total decentralized organization without central authorities, but it raised a lot of money. But they're using the Ethereum blockchain for that. But there are some people I work with who are actually experiencing this to actually have a DAO, but for connected devices. So that's all I had. So thank you for listening. If you have any question, thanks.
Thank you, Sam. We indeed have 10 minutes for questions.
Oh.
Who wants to fire the first one?
It's a bit too hard, it seems.
I have one. At the last PyData conference, there was Trent, I can't remember his surname, talking about a new blockchain database called BlockchainDB. Have you heard about it?
BigchainDB.
BigchainDB.
It's called, yes. I know about BigchainDB. It's a really interesting project, actually. You see that the thing that the guys on the BigchainDB try to do, instead of going through, I have a blockchain, and then build a database or a data access layer on top of it, like you would think to do. They went with a distributed database and added the concept of blockchains on top of it. So they try to take the good ideas that you have into blockchain, but actually create a database. It's still in its infancy. I haven't used it for real application yet, but it's something that's really interesting that I'll look into. It's very nice. And I think they're picking up some steam now, because when people are interested in actually having blockchain, it's not just for toy project like I do, or for Bitcoin mining, these kind of things, but actually for storing data, because the ideas are there, because you have limitation that you have in most data today. Is you have privacy, auditability, with this kind of thing. So bringing them into the world of databases is quite interesting. And one thing, for example, that's going on is actually people building data processing for risk. Where, for example, you have derivatives of financial risk using the data, the blockchain or Bitcoin or Ether for that, but actually using low power devices that run the processing in the in the blockchain. So they're doing this kind of work. I think we're still at the very beginning of this kind. There's still a lot of talk when it comes to blockchain technologies today, but there are also real projects going on. And BigchainDB is a nice project as well. Yeah.
Any more questions?
I guess we could.
Okay, so thank you very much for coming. Let's thank Sam
Thank you.
one more time.